So, a bit about myself and why you should hopefully listen to me. I have been in technology industry for over 25 years now. I have done everything from technical support to systems architect to developer to senior developer. I have been the CEO, systems architect, angel investor. And on top of that, I have been in open source for 30 years now. In fact, I owe all my IT knowledge, my computing knowledge, to the open source communities, to the kind strangers on the internet who are willing to share their information and their tools with me. Presently, I am a partner with Bitergia and a senior consultant there. And I am a acting vice president of the Open Tech Association of Thailand, as well as the organizer of FOSS Asia, Asia's largest open source conference. Open source, open collaboration, agile has been so influential for me. I believe it's so much that I have decided to homeschool my kids, to apply the open source principles, the agile principles to homeschooling my kids, and I have given a TED talk on this TEDx talk. So this is where this lovely photo of me comes from. A bit about Bitergia. Yuki-san had given a brief introduction. So Bitergia has had more than 15 years of experience helping software development teams work more effectively using a very metric and scientifically driven approach, an evidence-based approach. So they have founded the Chaos Project in 2017, which helps to bring this metrics-based approach to open source communities, as well as InnerSource teams. They maintain the open source GrimoireLab metric tool and are the official metric partners of Open Infra and NumFocus Foundation. So the Bitergia works in two parts. One is the consultancy, where we do the strategy and the analysis, as well as and there's also the analytics platform for the where we do the reporting. So these two go hand in hand, and that's what I think makes Bitergia a really great place to work, because many consultants will come in with very little evidence. Right, with Bitergia, everything is metric driven. So you have a hypothesis, you test it, and see if the metrics work out. That makes it a lot of fun. And we have been trusted over the years by many organizations. These are a small list of Bitergia's clients, past and or present. So let's start with some questions. Please scan the code. What is your favorite manga or anime? Romanji, please, or hiragana.
Or even Thai.
Or Thai. But I think everyone can read Romanji. Mine would be Akira, Dragon Ball. I also really like Attack on Titan. I short.
Yeah. Four. Slam dunk.
Slam dunk. Okay.
You know that?
Yes. Yes. Well, I have not read it. Attack on Titan. Excellent. Naruto. Choice. Doraemon. Which geek does not love Doraemon? We have a few more seconds. So this is the only reason I'm here today. For recommendations.
I assume we are 11, so
Yeah.
that's all.
Thank you. So let us start and continue with the next one. Do you have an InnerSource program in your company? Yes, no, or not sure?
はインナーソースをやろうっていうまとめ役の人が簡単に言うといるかみたいな話ですね。
It's okay to not have one. Yes, one person has one. Even yes and a no. A lot of sad faces. Well, at least there's no not sure. We have heard of organizations that have something that they say is InnerSource, but looks nothing like InnerSource. Fake InnerSource. Okay, thank you. Yeah, 3 yes, no, 8 no. Okay. So we're here today to break down silos. Why do you want to break silos in your organization? Cost savings, knowledge sharing, creating reusable software, increased development speed, employee satisfaction and talent retention, improve quality, innovation, or others. You can select as many as you like. Okay, so this is somewhat evenly distributed out, and I'm happy that very few people have chosen cost savings. So we can have a more in-depth conversation about breaking down silos. And yes, these are some of the typical scenarios that we have seen about breaking silos, and I think it's pretty comprehensive, because there's no one listing any other reasons under others. So let's begin with, how confident are you about breaking silos in your organization? I hope the translations came out correctly. Correct. Thank you. There's 30 sad faces. So very unhappy. This is normal, right? It's an unhappy face. And this is normal. Breaking down silos are hard. Breaking down silos are extremely difficult, because you go up against cultural inertia, you go up against politics, you go up against legal issues sometimes. And more importantly, people don't like change. We often notice that, especially large organizations that have many employees, but even small organizations, because people are too busy to change the way that they work. But we have to start somewhere if we want to see the changes. So let's talk about silos, right? For those who are not so aware, what are silos? Silos are a way of looking at organizations. We say that each business unit, or sometimes each department, or even sub-department, works inside their own silo. the smallest silo I've seen is the silo of one person in a company of 7 people. There were 3 different silos in a company of 7 people, right? They each person in their silo did their own work without speaking to the other people as well, because they consider that I have done my work and this is what I am paid to do. And the others don't really matter. The other people are the boss's problem, not my problem. But this created in that organization a collaboration issue because the output was becoming problematic because people were not really discussing or agreeing what the output should be. So we have silos, right? And these silos, they produce, they need to use tools. So let's say the tool is a hammer and a spanner. So they buy or they make the hammer and the spanner for use inside their department. Another silo also uses a hammer and a spanner, but they don't talk. So they start from scratch from the beginning and get their own hammer and spanner. A third only needs a hammer. So they go through the process of making their own hammer and so on and so forth. In the end, you have each silo making their own variation of the hammer that they have made and maintained all by themselves. And they are very, very proud of their hammers because they have put in a lot of hard work, blood, sweat, tears, budget into these hammers. But each department, if you are in one of these silos, you have to go back and ask yourself, do your customers pay you for your hammers? Right. Because unless you are a hardware company, the customers are not paying you for your hammers. So no matter how beautiful your hammers are, I'm sorry, the customers are not paying for that. They are paying you for what your hammers hopefully makes, this is part of the lean principle, right? The continuously improving your process to eliminate waste and increase efficiency. And what is waste? According to lean, is the action that's not delivering value to your clients. So if we have physical hammers, all this is okay. Each silo needs its own hammers. But if we are, but remember, we are talking about digital artifacts, right? Well, we're not talking about real hammers. You're talking about digital tools. The hammers are only metaphors. So back to our hammers. In order to remove waste, let's remove these silos. Let's take all our tools and put them in a central place. And because this image features a sky, conveniently, there are clouds. So we put these tools in the cloud. Right? And the difference between sharing a physical item, such as a hammer, is that sharing physical items is a zero-sum game, which means if I have a hammer and I give it and I lend it to Yuki-san, Yuki-san has a hammer, but I don't have a hammer. But if you give away code, if I give Yuki-san code, I have code, Yuki-san has code. It benefits everyone who participates in the sharing. And the tools become better because it has been tested against different conditions. So I have tested it. Yuki-san has tested this. Everyone here has tested the hammer, right? If the hammer doesn't work, if it breaks, if it rusts, someone here in this room will report back, and we work together in creating a better hammer. So the responsibility does not lie in any one department. The work can also be distributed out toward different silos, depending on what you are good at. right? So one part of the silo can take care of just the enhancement, another bug fixes, another takes care of support, another education, another security, so on and so forth, right? So the resources available to work on these tools is multiplied by several times because you don't have to do everything by yourself anymore. You can split it up. At the same time, so the resources available is multiplied. At the same time, the resource required is a fraction of the original setup, right? Because, for example, before, so let me put this another way. If initially you had to do everything, right, and now you only had to focus on one part of the problem, suddenly you have the amount of improvement that goes into any single thing can be multiplied by 5, by 10 times under this scenario. So breaking down silos increases the efficiencies, and with the help of InnerSource, it frees up your resources to pursue more demanding projects that hopefully makes your customers happy. Now, in order to do that, we use the goal question metric framework, which was developed by Victor Basili in the 1990s, I believe. This way, we can have a more meaningful conversations about what goals we're trying to achieve and the metrics that will support our goals. So, for example, the goal is to improve customer satisfaction with our software. The question can be, how often do customers encounter bugs or issues with our software? The metric, customer reported issues, the number of customers reported issues per month. The question can be, how easy is our software to use? The metric can be a usability rating, some sort of subjective rating of how easy the software to use as reported by customers, or usability testing. Right. So what I have put on the slide here are keywords for some pretty good goals, right? Bug fixes, enhanced security, better support, better resiliency. They are things that could make up good goals. So now let's go to metrics for a moment. Metrics are tools that help us measure how well something is doing. When you are driving a car, maybe your metric will be kilometers driven, right? If we set the air conditioning, a metric can be the temperature. It gives us a measurement to see how well something is doing. It gives us information to evaluate progress and make smart decisions. So you can use metrics you should be able to use metrics to track progress, compare things, and make decisions. But metrics are only useful if you know what you're trying to do with them. Good metrics are easy to collect. They are easy to understand. They are tightly related to the question and expected outcome. And they should be useful, if not very informative. They don't have to be very precise. They can be relative, but they have to be good enough to see the changes. So it is important to be strategic with your metrics. We go for the goal question metrics, right? But then there is also a second part to it, which is the plan, do, check, act cycle. So why the plan, do, check, act? So there's a story that is commonly told in the data science field. A police officer comes across a drunk man fumbling around a streetlight. The policeman asks, "What are you doing?" The drunk says, "I'm looking for my keys." The police asks, "Are you sure you lost them there?" The drunk man replies, "No, I lost them over there," pointing to the dark alley. The police asks, "So why are you searching here?" The drunk man says, "This is where I can see." So when you have metrics, when you are measuring something, right? Oftentimes, that is all that you can see. there are limits. For example, you can't X-ray people's heads, right, to measure productivity. So we can't do that to measure whether our developers are thinking about code or Naruto, right? So we often can only use what we have in order to gather the metrics and make decisions. And we have to have different techniques in order to manage things with limited information. But we have to understand that the information is limited and is not always the most useful information, because the most useful ones may be too difficult to measure. So which is why we have a process of plan, do, check, act. So an example of a PDCA cycle is that you can start with identifying a high rate of customer reported bugs, right? That is the plan, to identify a high rate of customer reported bugs and set a goal to reduce the number of bugs by 50%. Then you implement a new testing process to collect the data on bug rates. You analyze the data. You find that it has reduced by 40%, and then you make adjustments to the testing process to continue to and to monitor the bug rate again. So you keep doing this until you make your target of 50%. So it allows you to break down big problems into smaller problems that you can work on. And this is really cool. This is the metrics example from IBM Watson in their natural language processing program. This was originally given by Jeffrey Burek last year in Japan. And he talks about how IBM's artificial intelligence project had gotten behind because their development was hobbled and siloed. And after they started using InnerSource, the team started working together to create reusable components that were shared. And then all of a sudden, IBM was back in the game again because they could multiply the resources. So this is the innovation flow. We start with a contribution, right? On one side of the innovation flow. And on the other side, we have the adoption. So with any software project, you need our InnerSource project, you need to have both to make it balance. Now, what is interesting is that in his slide, he presented metrics. So we have the metrics for the contributions. You can see here, there are 50 contributors and 12 maintainers for their projects. And then we have the adoption. We see that there's 700 users, 15 products teams in the first 18 months. There is 75% less time to value delivery and $10 million saved just through code reuse alone. Right. So this is what I was talking about, the benefits of breaking down silos. And IBM has had a huge impact with just a small part. Well, I'm not sure about small, but a part of their organization. So let's look at some pretty pictures. One technique of using metrics to break down silos is to see which contributors or business units interact the most. Right? We can use the network analysis method. So in a nutshell, we start off with a project. It can be code, a document, anything really. The project has a developer working on the project. We put in a graph to show that the developer is working on the project. And then in a silo organization, we will see something like this. We have project A with the developer A. We have project B with the developer B. Everyone is contributing to their own projects, right? When you start breaking down silos, you see this. You see the developers working on other projects as well. This implies a flow of code, a flow of information going between the projects. When you put it all together, you get beautiful graphs like this. Okay. And this is all visualized using GrimoireLab. It's an open source project, so if you want to load it and play around with it in your own organization, you are most welcome to do so. Right? And you can see many things. You can see continents, right, which are big projects with a lot of contributors and a lot of cross-project contributions. You can see archipelagos, which are islands. You have a bunch of projects in the middle, and you have supporting smaller projects around the outside, right? You can see patterns like this. So you can see on the left, you have one project. You can see developers contributing to only one project. And sort of in the middle, you can see in the dotted lines, you can see some developers contributing to more than one project. And remember, if you have ever studied biology, this process of contributing to more than one project sometimes or oftentimes has the same advantage of pollination. We see bees going from one flower to the other, taking genetic information and spreading it around. Oftentimes, we see this effect where all it takes is a bunch of contributors to go hopping and learning between projects to invigorate the projects and turning a dull, dying project to a dynamic one. We can also see examples between collaboration, projects with high levels of collaboration and those that are relatively isolated. And then we can see another pattern of siloed organization. So these may be large business units, right? But then they don't talk to one another, and you can see it between the lines, right? It's split up between up and down and left and right, and they don't talk, right? So GrimoireLab, it's an open source project at the Linux under the Linux Foundation. It collects and displays data. It supports over 30 development collaboration platforms. And there are many metrics that are included as part of this. Right. Now, I've spoken a little about metrics, but this information about metrics needs to be shared. It needs to be developed together, right? Because if each of us works on our own metrics, we only have one street light worth of light. And we don't really understand, we may never find the keys, but hopefully we will get closer with everyone's help. So there is a pattern for introducing metrics in InnerSource. It is an open collaborative project, and we would like to have your input, whether the suggestions in here work or not with your experience, where the problems are, or if you have any further ideas to contribute, all are welcome. And especially if you do not have much experience, you are even more welcome because you come to this with fresh eyes. So let us build on that a little bit. I will go into a lot of details, so if you fall asleep, don't worry about it. Okay. The network graphs are eye-catching. They're really, really beautiful. But then you need to approach it with a trained eye. You need to know what you're looking for. The heat map on the right is easier to look at. So if you have a repository, a project with more collaborators, it will be a darker color. This will allow us to see the repositories with more collaborators. And where it gets intense and you attract a lot of collaborators and which projects are lacking. So we can build the visualizations for the repositories that we are interested in. Also, on the left, you have a table of top external contributors, which allows us to see the most active contributors. These can also become the next trusted committers, basically people who help you take care of your project.
If possible, could you explain a little bit about trusted committers?
Trusted committers, certainly. So let us use Yuki-san as an example, right? Yuki-san has written a whole bunch of documentation in Japanese in the InnerSource Commons project, right? He has put in a lot of hard work. I come along, I'm very excited and enthusiastic, but I speak very little Japanese. I come inside and I started making changes to his document, right? Now, the thing is that if I make changes, the quality of the documentation could have gone down, right? It could be that I may have some of the right ideas, but my level of Japanese skills is not good enough for the documentation. It could be grammatically incorrect. It could have spelling mistakes. I could use absolutely the wrong kanji for the word. So which is why it is good to have someone who's experienced, who really cares about the project, who understands it, to be the trusted committer of the project. So I would submit in a change request of some sort. In GitHub, it would be a pull request. In other management systems, it would be called something else. But there will be a series of people called trusted committers to look at the contribution, right? So in this case, Yuki-san would be a trusted committer. He will look at my contribution and he will say, Mishari, these are some good ideas, but there are still issues with it. Please go and change A, B, C, D, and try again later, right? That will be his job. So this is an example about a documentation, but it could be, for example, source code that is used to control your automation, or part of the code used to handling your client's billing, right? Things that you don't want people to contribute to without at least one layer of check and balance, right? But also a trusted committer's job is to help build the community, to put out information about what the standards are for contribution to the repository, to write documentation, to help answer some of the questions, and to basically make the repository a nice place to contribute to. Did that make sense, Yuki? Anything else I missed? Okay, thank you. So the way to do this is to use policy metrics, right? In order to use policy metrics will allow you to use metrics to help break down silos, right? So one of the goals for breaking down silos is to increase coding collaboration across silos, right? So you might want to figure out why this is not happening, why people are not contributing across the silos. So you would use the root cause analysis, right, to figure out, to go deep, to figure out why people are not contributing across your repositories, across your silos. So in this case, for this example, we have found that the commits are too big. Each time people submit code, they submit 100 or 1,000 lines of code, which is way too big. And so the reviewers, the poor trusted committers, has too much work to review all this code. And so it falls behind, or the change request gets rejected. The person who spent all that time and all that hard work submitted in the code just to have it rejected, then decides that they don't want to contribute anymore. And so that's when we establish a strategy to ease the reviews, to make the size of the contribution smaller, based on this new policy goal, right? Break PRs into more and smaller commits. So then we have a bunch of questions, right? Remember goals, question, metrics. So we have developed. So we have the policy now. We have a bunch of questions. So how far and well are we applying our policy? Is the policy succeeding? Are we being misled by circumstances? Are we causing unwanted side effects? Right? And then we come out with all the metrics that will support it. So the idea is that with all of this in place, your code, their commits should flow better. So the policy and context metrics are not really tied to our business goals, but then they do play a supporting role. Right? But remember, metrics are very, very slippery. It is very easy to get it wrong. And you can see, based on this image, the part on the bottom is all the factors in favor of this pattern. The one on top are the factors working against it. All right. So which is why it's very important that if you are approaching the problem of metrics is to please seek help. There is the community that is willing to help you, or if you want to talk to experts, there's Bitergia and others who are willing to help you out. But please be very, very careful about going at it alone. Now, everything that we have spoken up until now, basically we are standing on the shoulders of giants, and the amazing, amazing work that has been done by all the participants in the InnerSource Commons community, as well as the chaos community. It's not an exclusive club of smart people, but it's composed by regular folks like us who have had experience, who are coming in to answer, to ask questions, to help each other answer them, and to find our way through a very difficult problem. And slowly, hopefully, one step at a time, we will be able to keep making this better. Okay. So in summary, I would like to invite you to implement the metrics, right? When you start breaking down your silos, implement them early on in this entire process, and please don't make up your own metrics without support. Seek the help of the community. Another thing is that I just wanted to bring this forward. If you love technology, if you love the open way of working, if you want to see what is happening in the at the cutting edge of technology, there is a saying that if you want to know what is the future of technology, you should see what the geeks are working on the weekend. So many technologies such as that we know, such as Bitcoins, right? Blockchain, lately, many of the AI tools that we see today was started off by geeks working on the weekend on solving a really cool problem. And so, and also everything that you have seen here, the open collaboration is also, which has become InnerSource now, also start off in open source communities. And what we're having is that in the 13th of April to the 15th of April this year, we are going to have basically the largest gathering of open source practitioners in Asia, in Singapore. So if you have some time and you'd like to come and meet cool people doing amazing work, and you are interested to see about the future of technology, about the future of DevOps, about the future of AI, and where we are going to be headed in the next few months or the next few years, please drop by our event in Singapore. I will be looking forward to meeting some of you there. So we have gone through that, and this is part of my PDCA cycle. So after the presentation, how confident are you about breaking silos in your organization? Are you feeling a little bit better? Do you have a few more tools? Okay, the graph is moving a bit left. A lot of confused face. That's okay. Okay, well, feeling a bit better. I'm happy to see that. I'm happy to see that my brief time here has led to some impact, and hopefully has given everyone something to think about, some things to Google and to reference going forward. And of course, I'd like to remind you that the community is there. You don't have to do this by yourself. We have all had to deal with bosses, co-workers, and other people. And we are coming up with ways of how to communicate the benefits to them so that we can all have a happier, more collaborative, and a cooler workplace. I would like to, with that, I would like to thank and acknowledge ChatGPT for some content editing. The gray silo photos are from a leaflet in Wikipedia. The slides from InnerSource at IBM Talk is available at the link, and the drunk man under street lamp was generated by Stable Diffusion.